Force, mass, and acceleration. In this tutorial, we'll learn more about each component and how they are related to each other. The force, we discussed the force thoroughly in chapter 2, and we said that it is a push or a pull on an object. For example, the weight force or gravitational force, it pulls the object downwards. Now, the mass is the quantity of the matter found in an object. For example, a mass of a body equals 60 kilograms. And the acceleration that we explained in chapter 1 is the rate at which objects change their velocity. For example, acceleration of the moving body equals 100 meters per second square. Now, what is the effect of force and mass on acceleration? First, we need to know that an object will not change its velocity, which means accelerate, unless there is an unbalanced force acting on it. For example, in the cable car we have thrust or forward force, air resistance and friction with the cable's opposed motion. So the cable car moves with a steady speed, no acceleration. The forward force on the cable car should be balanced with the friction and air resistance forces acting on it. The unbalanced force or the net force is 0. So we can conclude that at a constant speed, the unbalanced force on an object is 0. Also, we can conclude that if there is unbalanced forces acting on an object, then the object will accelerate. And we can say that the acceleration depends on the size of the unbalanced force and the mass of the object. Now, to understand this point more, we'll go back to the book, page 23, figure 3.2. In the first part, we have two masses, a small and a large one. We notice that the small mass has large acceleration, while big mass has small acceleration. When the same force is applied to objects with different mass, the smaller mass will experience a greater acceleration. Now in the second part we have equal masses, but the first mass, bigger force acting on it. That's why we have larger acceleration. Different sized forces are applied to objects with the same mass. The small force produces a smaller acceleration than the large force. Now we can conclude from this figure that as the mass of an object increases, its acceleration decreases. And as the force acting on an object increases, its acceleration also increases.